Hello friends, in this lecture we are going to learn about classless IP addressing. Okay, so last time we learned about classful IP addressing where we saw that our addresses could be categorized into class A, B, C and D, where class A had 8 bits for the network ID and 24 bits for your host ID. Class B had 16 bits for your network ID and 16 bits for your host, and class C had 8 bits for the network, 24 bits for the network ID and just 8 bits for the host ID, and so on. But the problem was that in class A there were very few, just 2 to the power of 8 class A networks were there, which is 256, and each class A network has so many hosts. So you can guess that it has 2 to the power of 24 hosts, which is too much for any of organization, however big it may be. Okay, so this way a lot of addresses, IP address, which is a very costly resource, is wasted. Okay, it's just wasted. So this is not a very good idea to waste IP addresses when you have it very few of them. Okay, B, for class B, still it had 2 to the power of 16 addresses in each of the class B networks. Here also there was quite a few wastage. Class C now has many networks, but it has just 8 hosts for the one network. Okay, 8 bits for the net hosts and 2 to the power of 8, so 256 IP addresses. So this became a bit small, and D in fact smaller. Okay, so this way it was not very perfect. It was kind of rigid, that okay, only these classes are there. What if I want that okay, I should have 2 to the power of 12 hosts? It's not allowed here. What if I want 2 to the power of 10 host? Again, not allowed. So if I want to be flexible enough, okay, so what should I do? So here is the solution: classless addressing. Okay, so it provides you with different sizes of your network. So in this particular lecture, our objective will be to understand the classless addressing mode and look at how do we define the network address. Okay, and then what should be the size of the network, how are the first and the last IP addresses known, how to create subnets, and so on. Okay, so let's first find the definition. In a classless addressing, variable length blocks are assigned, okay, and they are not belonging to any class. In this architecture we have 2 to the power of 32 addresses. It's divided into different sizes block. Okay, you don't have a fixed size that okay, it should be 2 to the power of 24 many hosts should be there, 2 to the power of 16 or 2 to the power of 8 hosts can only be there in a network. You can have now 2 to the power of 20 hosts if you want, by having just 12 bits for your network and how many, so 20 bits for your host ID. Okay, you can have a network with 2 to the power of 12 or 1024 into 4, so something around 5000 hosts, by having 20 bits for your network and 12 bits for your host ID. Okay, so this way your network can become a little smaller. Okay, and you can have the flexibility, that's most important. Okay, so now this address space, this figure just tells that okay, your sizes can be different, but there are few restrictions, two restrictions as such. What are they? The beginning address should be divisible by block size. Okay, your network where it starts, so there should be a block, so block will have a starting address, okay, and an end address. Okay, and you should have a block size that should be a power of 2. These two restrictions, first and second, should be there. Okay, and that is important. So first one is important because of something like, if we have, let's say our network size is 512, it is a power of 2, this is fine. Our starting address, if it is, why should it be divisible by the block size? So it means starting address should be something like 512 A. Okay, then what will happen? My end address will be, what will it be? It will be adding 512 to it. So now what happens? This means that again, because 512 is again divisible, this block size will be added, so your end address will also be divisible by your block size. Okay, and then we can start new blocks. Okay, so this way 512 size block can start again. Okay, so something like this. So let's try to see. You can represent your IP address in this format. Okay, so let's try to see. Your IP address can be written as 831. With these A31, A30 are all 01 binary number. They can be either 0 or 1, and it can continue till A22 square plus A12 to the power of 1 plus A02 to the power of 0. This will help us in finding divisibility. Okay, so if I say that, okay, our start address, you are given some number, to find that if start address is divisible by, let's say, 256, what you need to do is that 256 is 2 to the power of 8. So your IP address will be A31 2 to the power of 31 plus A30 2 to the power of 30, and it will go up to A, let's say, A8 2 to the power of 8 plus A7 2 to the power of 7 plus A1 2 to the power of 1 plus A0. Okay, so this is there. Now whatever may be here, okay, 1 0 or whatever, this everything will be divisible by 2 to the power of 8. I can take 2 to the power of 8, it will be A31 2 to the power of 23 plus A30 2 to the power of 22 till A8. So this is whatever be the A31, A30 and so on, this part will be divisible by 2 to the power of 8, which is 256. So if your last number in the decimal, dotted decimal format is divisible by 256, this whole thing will be divisible by 256. Okay, so this way we will use to find, okay, what if your IP address is divisible. Okay, can it be a block size number? Okay, so let's see a few questions to understand the concept. Which of the following can be beginning address of a block that contains 16 address? Okay, so 16 addresses if you have in the block, your first block, okay, the beginning address should be divisible by 16. So this question now becomes very simple with the previous idea. I have IP address as A31 2 to the power of 31 plus A30 2 to the power of 30 plus A8 2 to the power of 8 till again, so A5 2 to the power of 5 plus A4 2 to the power of 4 plus A3 2 cube plus A2 2 square plus A1 2 to the power of 1 plus A0. Okay, so now whatever be here, so these are all divisible by 2 to the power of 4. We just need to check here. Okay, so in this one you can write, let's say, so this is 2 to the power of 5, your last 8 bits. So 0 1 2 3 4, 2 to the power of 5 is 1, rest of them are zeros. Okay, so we have here till A3 we had to check, so all are zeros. So this number is divisible by 16 because 0 is divisible by 16. So what we do, we will say that, okay, this number is divisible by 16. So this is can be the first address of a network with block size 16. This number 80, let's try to see, 80 is 64 plus 16, I think, yeah. So here it will become 64, this is A4, so A6, this will become 1, 16 is 2 to the power of 4, so this will be your, so again what will happen is last 4 bits are all 0, so this will be also divisible by 16. This one, let's try to check, 52, so this is 40 till here 12, so it means 8 plus 4. So now what will happen, this one will become 1, this one will become 1 0 0. So this is now, this number is 12. 12 is not divisible by 16, so this will not work. Similarly 44 will also not work, okay, because 44 is 32 plus 8, so 40 plus 4, So again 8 plus 4 will come, this is not divisible by 12. So this question we could solve, okay, and we don't have to divide this, I don't have to convert this IP address to completely decimal number, okay, with partial conversion also I can do. So here this is the solution you can see, but that was much easier. Now it says that which of the following can be beginning address of a block that contains 256 addresses. Okay, so again 256 is 2 to the power of 8. So A31 2 to the power of 31 plus A8 2 to the power of 8. So till here everything is divisible by 2 to the power of 8. So this one becomes A7 2 to the power of 7. This is the just the last byte, okay, so this part. So if this is divisible by 256, your answer is divisible by 256. 32 is not divisible, 0 is divisible, 0 is divisible here. So these two can be the first address, beginning address of the block. This cannot be. So your answers are, again here it says B and C are the addresses. Okay, so this is also fine. Next comes 1024. So this is again, so this is the same idea, mathematical idea. 1024 is 2 to the power of 10. So you go on till A31 2 to the power of 31 till A10 2 to the power of 10. So here till here whatever is there you don't need to consider, everything will be divisible by 2 to the power of 10. So A9 2 to the power of 9 plus A8 2 to the power of 8, A7 2 to the power of 7 till A0 you should think. Okay, so now what will happen, let's try to see the bits of here. So let's try to check for this one, 32 and 37. Let's try to check the binary number. So 37 is 32 plus 4 plus 1. So 1 2 3 4 5 6 7 8. So this is 1. 32 is 0 1 2 3 4 5. So this is 1, then 0 1 2, this is 1, and this is 1. Everything else is 0. So here, and so what happens, last two bits for this 37 is 0 1, okay, this is there. So this is just, and then the last bit is 32. So this is just the decimal. So 32 plus 1 into 2 to the power of, so this will be 2 to the power of 8. So 2 to the power of 8 is 64 plus 32. So this number is 96, is not divisible by 1024. Hence this overall, this number is not divisible. So this cannot be the beginning address. Let us check this one. So last part is white is 0, and then we need to find A9 and A8. So A9 and A8, because 32 is again just this bit is there, so A9 and A8 will be 0 0. So this will be all 0. So this number is divisible by 1024. So this will be there, okay, and you can check for all others like this. This will be 52. What are the last two bits of 24? So 16 plus 8. So again, so what will happen, your A9 and A8 will be 0 0, and then what happens, this was for 24 and 52. So A9 and A8 are 0 0. So 52 is not divisible by 1024. So this also will not be there. Okay, so this is the way for solving. I hope you understand this. Now what about format of classless addressing scheme? So it's x.y.z.t/n. Okay, so this is the format for classless addressing. And what happens is, if you have, these are the masks that are shown. Okay, so how to find the network part. So for example, if you have a /8 network, then what will happen, this means your network part is 8 bits, so you apply 255 to it and rest of it. So this will be your network part. Okay, /16, then what is the mask, it is telling about the mask. that what is the network part. Okay, that n means what is the network part, how will you find. So you AND this your IP address with your network mask, then it will give you the network address. Okay, and it is the beginning address. So what is the first address in a block if one of the addresses is this? So let's try to see this interesting thing. So you are given the first address in the block. It's asking if one of the addresses is this. If one of the address is this, then what happens? And this is your network mask. So what will happen? You have all the first 27 bits as 1 and rest of the 5 bits as 0. And you write the bit representation of this and these two, and you will get the number that is the first address or the network address. So the prefix length 27, which means that we must keep the first 27 bits as it is and change the remaining 5 bits to 0. The following shows the process. So address in binary for this one is there. Okay, so this is the first decimal, second, third and fourth. We keep the left 27 bits, okay, and rest of them we put at 0. So the address becomes 167.199.170.64. okay, so we just need to check the last address. Okay, so what is it? 82. 82 can be represented as 01010010, and you need to have 27, so last 5 bits you are 0, okay, and only 3 bits are 1. Okay, so what will happen? So we will get 0 1 0 0 0 0 0 0. So this is 2 to the power of 6, so that's why 64 we are getting here. Okay, so this is there. So you get the network address or the IP. The first address of the sub network is the network address also. What is the first address in the block if one of the addresses is this? Okay, so now the network address is 20 bits. So you have find the binary representation of this and then make the last 12 bits as 0. Okay, and keep the rest of the bits. So the first, second and the fourth bytes are easy. Okay, how and why? Okay, let's try to check. So here what happens, only the last 12 bits we want to make 0. Of these I want to make the last 12 bits as 0. So what will happen? Last 12 bits means last 8 bits will be 0, so the last decimal will become 0. Now 84 is 64 plus 16 plus 4. So this is, so I can write it like 2 to the power of 6 is this, so 1 0, and this is 2 to the power of 6, 2 to the power of 5 is 0, 2 to the power of 4 is there, 2 to the power of 3 is 0, this 2 square, 2 to the power of 1, and this is the binary representation of 84. And in this what we do, so last 20, so last 20 means here we are making the last 4 bits as 0, these as 0, so the number is just 64 plus 16, so 80. So our network address is 140, 120, these are all ones ANDed with 1, so they will remain the same, 80.0 slash. So this will be the first address, so 140.120.80.0.